This is a Follett countertop ice maker dispenser. It dispenses water and it dispenses ice. We've hooked it up with a Hydroflow the proper way. The Hydroflow has got a ground wire that is running to an electrical ground. I've used a temporary grounding wire here. It wraps through the Hydroflow twice, and then it goes up to the auger where this antenna wire connects to the auger itself, and then jumps over to the front of the bin. This stainless steel piece is connected to, it's touching the ice inside the machine. We're checking our signal with the Hydroflow in motion, and I'm going to put it on to stop for a moment. And as you can see, we're getting about 7.5 volts on the front end of the ice bin. We're also getting the same reading on the auger itself. This is the proper way to hook it up. We're going to use a permanent ground before we wrap through the Hydroflow twice. We'll connect this to a plug that will plug into a power strip right behind the machine. But again, the proper way to connect it is a good electrical ground to a grounded plug through the Hydroflow twice, and then up to the auger and around to the front of the bin. And you will get enough signal to wipe out bacteria and scale in this machine. Now, in order to test this with my oscilloscope, the proper way to test it with the oscilloscope is having the oscilloscope ground lead connected to an electrical ground, but not wrapped through the Hydroflow. This blue wire goes up to my electrical ground on the plug. So both of these are hitting the same ground point. This one is wrapping through the Hydroflow 2 times and then going up to the auger and the bin. This one is feeding directly from ground to my Hydroflow, or to my oscilloscope ground lead on the lead. This is the hot lead on the oscilloscope lead, and this is ground. Now I'm going to show you what happens to our reading when we unplug the ground for my oscilloscope. You'll see that we're still getting a signal there because we're still reading through the air. But we're getting a lot more static, and our reading is not as accurate, and our voltage has dropped a little bit. We've dropped a couple of volts. I'm going to plug the ground lead back in for the oscilloscope, and you see that our voltage reading comes back up to 7-8 volts, and our signal is much more clear. Now I'm going to unplug the ground wire that goes through the antenna wire that wraps through the Hydroflow, and as I unplug it, you will see that our signal drops radically. We have no ground. We're still getting a Hydroflow signal, but our voltage is now only 2 to 3 volts as opposed to 6 to 7 volts. Now 2 to 3 volts is adequate, but the stronger the signal, the better off you are. Now the other thing that I've done is I have bared the ground wire here so that we can touch the ground wire the antenna wire that's going to the Hydroflow to the braided connection on the water line. And we'll see what impact that has on our voltage signal. Very little impact at all. But when I reconnect these, the wire connection came loose. When I reconnect my ground wire that feeds, or my antenna wire that feeds through the Hydroflow, and then plug it back in, as I'm doing right now, you'll see that our signal comes back to full strength. That's ungrounded, and that's grounded.